Hello, ladies and gentlemen. Welcome to my lecture on product sound design. I am very happy to talk about this very interesting issue. I am Ercan Altinsoy, Professor of Acoustic and Haptic Engineering at Technische Universität Dresden. I will start with a short motivation and introduction. After that, I will talk on sound design process and its strategies. I will talk also about some tools like Gestalt rules and also sound synthesis, and I will finish my lecture with some examples. Product sound design is a variety of communication engineering, deals with human and product communication, interaction, and is an integral part of communication acoustics. It is very multidisciplinary. It's based on the knowledge from acoustics, mechanics, electrical engineering, physics, also musics and perception. If I start with the introduction, actually we will talk today mostly on communication. And if we hear the word communication, we always think about the speech communication between the people. But in this lecture, if I talk about communication, I mean human-product interaction. And in the human-product interaction, it is a very important issue that sound is an important information carrier, which means that, for example, if I hit this table, you hear the sound, and you can easily say that, okay, it is a wooden table. You can also hear the metal or glass. It means that at 100 milliseconds, you get this information. In our daily life, of course, if we interact with products, we get always different information. And in some cases, this information are very useful for the interaction. For example, in a car, if I press a gas pedal, I hear the sound, and at the end also I feel the vibrations, and they are very important to get a feeling about the power of the vehicle, also about the velocity. Or if we think about a coffee machine, if we press the button, we notice that button sound and other informations give us important feedback about the process. Of course, in some cases, this information is not very useful for this interaction. For example, if we think about a refrigerator, it should function 24 hours. And if it says always, I'm functioning, I'm functioning, I'm functioning, it is always, of course, very disturbant. And in that case, we perceive this kind of information and at the end sound as a noise. And in that case, of course, for the product sound design, it is very important reduce or noise abatement. Today, also a very important point is that, of course, we can hear also quality and we can hear the product quality. At the end, sound is a hint for the product quality. Therefore, if we want to design a sound, it is very important to, of course, make it good and good hint about the product quality. If you think about our chain, in that case, we have some sources and they generate some sounds, of course, and at the end, these sounds will be perceived by a human user of the product, and the perception is quite an important issue. I would like to start with force. If we think about product sound design and strategies and tools regarding our product or source, sound source, of course, first of all, for us, quite important issue is the vibration generation, because the vibration and the sound are physically coupled. And therefore, we should think about the vibration generation, and therefore we simulate the vibrations, for example, using finite element model or boundary element models. Also, we use experimental methods to understand the vibration and sound radiation behavior. We need some other tools like transfer path analysis, because at the end we have a lot of sound sources, and it is like a composition of musical instruments. At the end, we should make composition of different sound sources. And at the end, of course, we define some constructional design issues, also vibration and sound damping and insulation. Today, I will not concentrate on these issues. Another important issue is, of course, also signal and the signal analysis, because as an engineer, we would like to also describe the perception, also source, using these signals and signal properties. Therefore, another important part of the product sound design is the signal analysis and psychoacoustical analysis, which help us to understand the perception. And in that case, we use, of course, different analysis. For example, in that case, I have selected Fourier transformation, FFT analysis, on the time axis over time. And in that case, we see the different FFT lengths. Same signal can cause different pictures. And this kind of pictures are quite important for us. In x-axis, for example, we see the time. It is time axis. The y-axis is the frequency. In the first picture, we see the 50 Hertz to 1 kilohertz. And the colors define the sound pressure level. High sound pressure level are represented using light colors, for example, yellow. And dark colors means that very low sound pressure level. And if we hear this sound and think about these both pictures, we notice that this sound has some temporal modulations, and these temporal modulations are much more better described with second picture. In that case, we have different FFT length. Also, in that issues for signal analysis, we use some filters, but also some psychoacoustical analysis, for example, loudness, impulsiveness, sharpness, fluctuation strength, roughness, or tonality. In other lectures, we'll talk about these issues also in psychoacoustic lectures. At the end, in the product sound design, also a very important issue is the user. We should always take into account the perception and the user. And of course, we should understand the user evaluation. And for that aim, we need, of course, first of all, to understand auditory aspects, auditory modeling. But at the same time, different customer groups have different tests and different expectations. Also, different cultures have different expectations and tests. Therefore, it is very important to understand it. Also, in our daily life, we perceive our world in a multimodal way. We use our eyes and at the same time our touch sense for the perception, and therefore multimodal interaction is quite important issue for the product sound design and the interaction between the tactile and visual domain. And also meaning assigning or analysis of the auditory communication process, which I will talk today, is very important issues. And of course, usability aspects and also brand design aspects. If we want to define the criteria for product sound design, good human product communication, as I already explained, that very important. At the end, we are communication engineers and we should define which information should be delivered and in which way. And we don't need some informations which are not relevant for the users. In that case, we should reduce them. at the same time, of course, emotional aspects are quite important, and also pleasantness. And of course, we should create some suitable sounds. It means that the sound which is suitable for shaver, it is not always suitable for coffee machine. In that case, it is always mostly dependent on the product and also context. And also, the identifiability is very important issue, and brand. At the end, most of the producers would like to also make noticeable that this product belongs to their brand. In this part of the lecture, I would like to talk on sound as information carrier and how important is the communication engineering for product design, meaning assigning. In this slide, we see classical communication model from the Shannon and Weaver. It was developed for telecommunication, and we see in this picture two people communicate with each other. But in most cases, such kind of communication models are quite useful also for product sound design. Why? Of course, in that case, in this model, it is very important to have some signs which can be understood, of course, by receiver and known by sender in both cases. And therefore, of course, coding and decoding are quite important issues. It is also very similar in product sound design. In that case, we have some products, technical products, for example, our vehicle or household products, and they generate some sound, and this sound gives us some information. And in that case, of course, very important that we deliver important information which is useful to use this product for the interaction with this product. Therefore, in that case, our engineering is quite important to develop some coding and decoding algorithms for the sound design. And in that case, of course, we have some other scientific areas which can help us. And in that case, of course, semiotics, the science of science, is quite important. And in that case, we have three groups. For example, index can be defined as a sign with a direct relation to the environment or natural aspects. Of course, in that case, direct means often even physical. And for example, footprints or thermometer is a good example for index. The second part is, of course, icon. Icon is a sign that represents an object by similarity. In that case, pictograms is a good example, visual example. And the third category is the symbols. Symbol is a sign of which the meaning is widely fixed by inter-individual convention. For example, white dove and cross is a good example. And these aspects are quite relevant also for product sound design. It means that at the end, in different levels, we can define our design issues and we can generate, for example, icons or symbols. And if we think about auditory communication, in the literature, we see that there are two kinds of important issues. One of them is auditory icons. In that case, we are talking about abstracted everyday sounds. It means that naturally occurring sounds. And in that case, we need some analogical representations. It means that we have some real-world equivalents. Therefore, it is much more intuitive and, of course, iconic. Another aspect is, or another issue is the ear cones. In that case, we are talking about short and structured musical messages. For example, tone sequences and arbitrary symbolic representations are quite good example for ear cones. in that case, we should learn these issues. Therefore, they are symbolic. And we can use different design features like rhythm, pitch, register, timbre, and dynamics. They are very useful to define or to design such kind of ear cones. Today, we will talk about product sound design. And in that case, we need some, of course, knowledge and tools for it. And in that case, Gestalt principles are quite useful tools for us for perceptual grouping, not for only visual system, also for auditory system. Therefore, I will talk about it. But before I will talk about it, I will talk also now about product sound design process. And I define 5 steps for product sound design process to make some good design. The first step is the communication engineering part, as I already explained that, the analyzing the product and its applications and the interaction with user. In that case, we need the informations which are important for the interaction, but also, of course, emotional aspects. And in that case, we use brainstorming to develop some ideas, which information is relevant for this interaction and communication with the product to use it much more better. And we collect these informations, select them. At the same time, emotional aspects also very important. It means that we don't collect only informations, also emotional aspects which are relevant to this product. And then we discuss about which informations we would like to have and which emotions we would like to deliver. And after that, very important point is the character and information encoding. I will talk about it later. In the second step, as I also talked on it, analyzing of the product vibration and sound generation is quite an important issue. In the third step, sound synthesis will be used, and therefore also in my lecture, I will talk on sound synthesis in the other part. The fourth step is the perceptual investigations using these synthesized sounds and selected criteria from the step 1. And at the last step, we combine all these steps and we try to make some targeted design, mechanical and electromechanical measures we define, and taking into account this information encoding and other issues, we try to develop some design, and at the end, of course, we would like to evaluate the design results. If we talk about information encoding strategy, which is very important for the product sound design, in this slide, we see an example. For information encoding, we have different possibilities. One is very good possibility, some evolutionary sounds we can use, because most of the evolutionary sounds deliver us typical informations. If we think about a lion roar, we know that if we hear this lion roar, all of us worry about it. Fear is an important information, but at the same time, we hear the power. And of course, if we think about product sound design, maybe fear is not so good, but power is a very important issue. And we would like to have good power in our products or give power feedback. Therefore, it is important to understand, first of all, in which part of the lion roar actually contains this power information. Therefore, we need some analysis on the time domain, frequency domain, to check out which parts are directly relevant to the power. If we understand and abstract these aspects, then we can try using, for example, our mechanical elements, our electromotors, and other issues, try to apply this code to our mechanical and electroacoustical systems and to generate sound. It means that instead of using loudspeakers, of course, we can use our combustion engine to generate some typical codes and give feedback of power. In that case, of course, user get information on the power. We have different strategies for the information encoding. We can use evolutionary sounds, or we can use also learned some signs and hints. And I will give an example for evolutionary sounds for product sound design. And in that case, for example, most of the evolutionary sounds give us different information, different feedback. And if we think about line roar, we all worry about it. And of course, first information which we get is the fear. But at the same time, we feel the power of line. And the second very important information, which is of course directly relevant for the product sound design, power. And we would like to, of course, have this power information if we think about different products. And in that case, for us, it is very important to understand that in the line roar signal, which parts are important, which codes are important for the power. Therefore, of course, on the time and frequency domain, we should understand which features are directly relevant to the power. And therefore, our analysis starts to understanding and abstraction of this code. If we understand this code, then of course we can apply it our products, technical products. In that case, we have combustion engine or other mechanical elements, for example, and of course we generate some tones, we generate some different noises, and if we know the codes, we can try to apply this code to our combustion engine or other sound source to give a feedback from the line roar as a power. Other possibility, which I will talk later, of course, we can also learn some informations, some signs. It is also a very important issue for the product sound design. But if we think about hearing, because the models of hearing are very helpful and useful for product sound design, in that case, of course, we can design or develop models which simulate how our ear functions, auditory system functions. At the first of the step, of course, we have antenna, also mass spring system. Therefore, we have a resonant frequency, which is very sensitive frequency for us. We have also amplifier, and at the end, our brain functions with digital or works with digital signals. Therefore, we should transform the analog signals to the digital signals. And these models function very well. But of course, for us, for the product sound design, very important issue how our brain, of course, give some meanings to these sounds. And in that case, we should understand also auditory processing. And in that case, of course, not only signal processing, also symbol processing is very important because our brain makes symbol processing. And we see here two signs, for example. You can easily notice that it is the number 9, but of course, they are designed in different way. And in one case, for example, in the second 9, almost missing a dot. And in such case, of course, our brain compare if it hears some sound, it compares with memory and tries to find if it can find any symbol in this memory, which is directly corresponds to the heard sound. And for example, in that case, number 9. And in that case, it says, okay, it is number 9. And if we want to understand such kind of issues, it helps us Gestalt principles for perceptual grouping, which I will talk about it in the next part.